Good morning folks, Ken Ring of www.predictweather.com. Today we're going to be talking about Jetstreams. Now I have a whole lot to tell you, so I'm not going to do it all in one go because you may go to sleep or I may go to sleep. But I'll tell you the whole story and I'll do it in layman's terms so that whenever you hear this word Jetstream from now on you'll know what it is. Because we've been reading about it in the papers lately that the Russian heat wave and the Pakistani floods have come about because of unusual jet stream formations. Well, listen, this is a subtle ploy to get the public wondering if the weather has finally gone completely nuts with respect to, of course, global warming and climate change. Well, don't fall for it. The jet stream is always there and it's never unusual. These things called jet streams, they're nothing more than waves, normal waves of air wandering around the Earth at very high latitude. You get the highest currents. It's the same in the sea. The higher the current, the faster it moves. And the jet streams in the air, they move from west to east. They also move from north to south. They're actually air mass dividers, and they come about as a result of cooler air on the move. Now, when you see a weather map on the TV, after the news, you can generally see areas of high pressure, they've often got an H, and areas of low pressure, they've often got an L, and between them are these isobar lines. And these H's and L's, they're high pressure, low pressure. You know, the high pressure areas, well, they go anti-clockwise in the southern hemisphere and clockwise in the northern hemisphere, and the L's, they've got clockwise formations in the southern hemisphere, anti-clockwise in the northern hemisphere. And yep, right between them there's always these faster winds, these isobaric lines, and they're tighter together. Well, as long as there's an atmosphere, there's going to be tighter atmosphere lines somewhere, isobar lines somewhere, and they will be the jet streams. The air is always moving. It's always moving fast in places, and there's always rivers of air, just as there are more powerful currents in the sea. There's sort of slow streams and there's fast rivers. The term jet stream, it's really just a buzzword. You know, we could just as easily call something in the sea jet waves, but it wouldn't mean much unless you're a fish. We actually live between two giant oceans. There's the one known as the sea, and there's the one known as the atmosphere. And one is wet all the time, and the other is wet some of the time. Although some would argue with that and say that one of them is even wetter than it should be most of the time. But anyway, the wind originates with movement in either the sea surface or high in the air, and they modify each other kind of in the middle of the sky. And on the sea surface, now the air and the sea are joined over 75% of the whole of the surface of the planet. And as the surface of the sea moves, well, by friction, it moves the air as well. And as it does that, it creates pressure differences above the sea. So, and it's in the direction the air is moving. So where the air is, that's a high pressure zone, and where it's moving into becomes a low pressure zone. And if that was not so, then there would be no movement possible. It's like two equal and opposing forces on a moving ball. The ball would stop rolling. Well, in the air, the same wave dynamics apply. And just as the moon moves the sea, it also moves the sea of air. Now, getting back to the sea, the moon moves the sea, the water sea, along because the moon changes hemispheres as part of a 27-day cycle caused by the tilt of the Earth. Now, it does it to the air as well. See, so if this is the Earth, it should be upright, and the moon should be coming around the middle of it like that. But the Earth is not. The Earth is on a tilt like that. So half of the month the moon is over the southern hemisphere, and then it comes around, and then it's over the northern hemisphere. And so it changes hemispheres every 13 days. And it shifts huge volumes of water around that end up becoming the tides, shifts them between the hemispheres. In this cycle, the moon pulls the air as well. So every 13 days it changes hemispheres. The air is light enough to move. It's 800 times lighter than the water, so it moves 800 times as fast. And so once a month The air is coming from the equator to the poles, and then it changes, goes from the poles to the equator. And that's what the air tide does. The water change, that takes about a season to change temperatures because the water is so much heavier. It's got a lag to it. Now there's also a vertical component to this business. It's virtually an up and down lunar displacement due to the fact that the moon comes closer every 27 days to the Earth, and so its gravitational force is the greatest when that happens. It's called the perigee, and that's what causes the biggest tides of the month, what we call the king tides, and that's the same for the whole Earth on the same day. We've just had them last week. Well, what happens is that the moon actually causes the jet streams to flow in a particular direction, and we'll talk exactly what happens there, how the moon does it, in the next part. So thanks for watching. Excuse me. Switch over to part 2 now.